14 questions were set from the chapter Complex Numbers in the January 2024 session of JEE Main Mathematics examinations. We have already covered the first 5 questions from the chapter Complex Numbers. We now discuss the next 5 questions, that is the question number 6 to 10 in this video. We first go to the 6th question. This question has appeared in the JEE Main examination held on 29th January 2024 in the second shift. The given question is, let alpha beta be the roots of the equation x square minus root 6 times x plus 3 is equal to 0 such that imaginary part of alpha is greater than imaginary part of beta. Let a, b be the integers not divisible by 3 and n is a natural number such that alpha to the power of 99 by beta plus alpha to the power of 98 is equal to 3 power n multiplied by a plus ib, where I is the imaginary unit. Then n plus a plus b is equal to. We are given a quadratic equation x square minus root 6 times x plus 3 is equal to 0. And it is given alpha, beta are the roots of this quadratic equation. And you have to choose alpha and beta as imaginary part of alpha greater than imaginary part of beta. Then you have to take alpha like this and beta like this. Yes. Let a, b be integers which are not divisible by 3 and n is a natural number such that alpha to the power of 99 by beta plus alpha to the power of 98 is equal to 3 power n multiplied by a plus ib, required to find the value of n plus a plus b. Let's now discuss the solution of the problem in detail. We are given alpha, beta are the roots of this quadratic equation x square minus root 6x plus 3 is equal to 0 with imaginary part of alpha greater than imaginary part of beta. Now, because alpha and beta are the roots of this quadratic equation, the sum of the roots alpha plus beta is equal to the minus the coefficient of x by the leading coefficient, that is the coefficient of x square. It is precisely root 6. And the product of the roots is equal to the constant term divided by the coefficient of x square, that is 3. Right. And we can also find out what exactly the roots are. So this is the quadratic equation. Use the formula x is equal to minus b plus or minus under the square root of b square minus 4ac by 2a with an appropriate ABCs. Then that will give you x is equal to root 6 plus or minus I multiplied by root 6 by 2. These are the complex roots what we got. Now let alpha is equal to root 6 plus I root 6 by 2. Beta is the other one, that is root 6 minus I root 6 by 2. Why I have taken this as alpha and this as beta? Because the imaginary part of alpha is root 6 by 2 is certainly greater than minus root 6 by 2, which is equal to imaginary part of beta. So therefore this is alpha and this is beta, and they satisfy this one. Agreed. Agreed. Now further, alpha is equal to, now in alpha, root 6 is taken out common. So root 6 by 2 is root 3 by root 2. After taking root 6 common, we will get 1 plus I. So it will be alpha is equal to root 3 multiplied by 1 plus I by root 2. And 1 plus I by root 2 is very familiar to us. This is e to the power of I pi by 4. E to the power of I pi by 4 is cos pi by 4 plus I sin pi by 4 is precisely 1 plus I by root 2. Right. Then beta will be root 3 times e to the power of minus I pi by 4. Minus I by 4 because it has a minus sign here. Agreed. Agreed. So alpha is root 3 e to the power of I pi by 4. Beta is root 3 e to the power of minus I pi by 4. Now let's go to what is given to us. Alpha to the power of 99 by beta plus alpha to the power of 98. Between these two, you take alpha to the power of 98 common. That will be multiplied by alpha by beta plus 1. Take the LCM. Alpha to the power of 98 multiplied by alpha plus beta by beta. And we know alpha plus beta here from here. Alpha plus beta is root 6. So alpha is what? Alpha is root 3 e to the power of I pi by 4. So root 3 e to the power of I pi by 4 to the power of 98 into alpha plus beta is root 6 by beta. Beta is root 3 into e to the power of minus I pi by 4. Agreed. Root 3 to the power of 98, that is 3 to the power of 1 by 2 to the power of 98, that is 3 to the power of 49. And this will be equal to 3 to the power of 49 into root 6 by root 3 is root 2 into e to the power of I 98 pi by 4. E to the power of I pi by 4 to the power of 98 is this one. And 1 by e to the power of minus I pi by 4, when you bring it to the numerator, it will be e to the power of I pi by 4. Agreed, agreed. Now multiply these two things. Multiply these two. So e to the power of 3 to the power of 49 into root 2 into e to the power of 99. Yeah, in addition, when you multiply, the powers will be added. I times 99 pi by 4. Now this is 3 to the power of 49 into root 2 into e to the power of I into 24 pi. Why 24? 4s are 96 plus 3 pi by 4. Agreed. E to the power of I 24 pi. That is, this is e to the power of 2 pi I to the power of 12. E to the power of 2 pi I is 1. So it will be e to the power of I 3 pi by 4 only. So that is that. Now expand this. 3 to the power of 49 into root 2 e to the power of I 3 pi by 4 is cos 3 pi by 4, that is minus 1 by root 2 plus I sin 3 pi by 4, that is 1 by root 2, that is minus 1 plus I by root 2 e to the power of I 3 pi by 4. So this will be root 2 cancels and you will get 3 to the power of 49 multiplied by minus 1 plus I. This is alpha to the power of 99 by beta plus alpha to the power of 98 is equal to this one. Agreed. But it is given this one is equal to 3 to the power of n into a plus ib. Now this is equal to 3 to the power of n into a plus ib, and this part is 3 to the power of 49 multiplied by minus 1 plus I is equal to 3 power n into a plus ib. And on comparison, what you get is n is equal to 49 and a is equal to minus 1 and b is equal to plus 1. So what is that we want? We want n plus a plus b. So therefore n plus a plus b is equal to n is 49 plus a is minus 1 plus b is plus 1. So 1 minus 1 cancels and you get 49. Therefore the answer to this question is 49. It is a numerical value type question. Therefore we get the answer. So that is the detailed discussion of the solution of the given question, and I am sure that you have understood the solution of this problem. Let's move to the next question. Question number 7, and this question has appeared in the JEE Main Examination held on 29 January 2024 in the second shift. The given question is, let r and theta respectively with the modulus and the amplitude of the complex number z is equal to 2 minus I into 2 tan 5 pi by 8, then r theta is equal to. We are given 4 options. So we are given a given complex number. This is the given complex number, and you have to put this one in the polar representation of the complex numbers. Right? That means you have to write this as r e to the power of I theta and find r and theta and find the ordered pair r comma theta from among the 4 options given to us. Let's now discuss the solution of the problem in detail. We have the given complex number z is equal to 2 minus I times 2 tan 5 pi by 8. For tan we have written as sin 5 pi by 8 by cos 5 pi by 8. Take the LCM, and that will be 2 by cos 5 pi by 8 multiplied by cos 5 pi by 8 minus I sin 5 pi by 8. It is cos theta minus I sin theta. Cos theta minus I sin theta is e to the power of minus I theta. So it is 2 by cos means 2 secant 5 pi by 8 into e to the power of minus 5 pi by 8 I. Agreed. Now can we now take this as our r, this as our theta? Can we take this? We cannot. Why? Because this is, if you say this is r must be positive. But secant 5 pi by 8 is not positive, it is negative. Therefore, you have to convert this into a positive quantity. How do we do that? So we will write this is equal to 2 secant pi minus 3 pi by 8 into e to the power of minus 5 pi by 8i. And if you do that, this is 5 pi by 8, and this is the answer is minus 2 secant 3 pi by 8. We have succeeded in getting secant 3 pi by 8 is positive. But there is a minus again. To get rid of this minus, we will multiply by e to the power of I pi. So this will be equal to 2 secant 3 pi by 8. This is r, positive, multiplied by e to the power of I pi into e to the power of minus 5 pi by 8i. Multiply these two. So that will be 2 secant 3 pi by 8 multiplied by e to the power of pi minus 5 pi by 8i. And that will be precisely 3 pi by 8. That is 2 secant 3 pi by 8, which is positive, that is r, into e to the power of 3 pi I by 8, that is r e to the power of I theta. R is 2 secant 3 pi by 8 and theta is 3 pi by 8i. So the ordered pair r comma theta is equal to 2 secant 3 pi by 8 comma 3 pi by 8. That's what is exactly wanted. And let's look for options. Our answer appears against option 4. Therefore, the answer to this question is option 4. That is the detailed discussion of the solution of the given problem. I'm sure that you have understood the solution of this problem. Let's move to the next question. Now go to the 8th question. This question has appeared in the joint entrance examination main held on 30th January 2024 in the first shift. If Z is equal to x plus iy, where the product xy not equal to 0 satisfies the equation z square plus I z bar is equal to 0, where z bar denotes the complex conjugate of z, then mod of z square is equal to. We are given 4 options, and we have z is equal to x plus iy, where the product xy not equal to 0, and thereby xy not equal to 0 will imply x not equal to 0 and y not equal to 0, and thereby x plus iy not equal to 0, and thereby z not equal to 0. And such a z satisfies the equation z square plus I z bar is equal to 0, then required to find the value of mod z square. Let's now discuss the solution of the problem in detail. Given z is equal to x plus iy, where the product xy not equal to 0, that will tell you x not equal to 0 and y not equal to 0, and thereby z not equal to 0. Therefore, mod z not equal to 0. Agreed. Now, z square is equal to I z bar, that implies z square is equal to minus I z bar, taking the modulus on both sides. Mod z square is equal to mod of minus I z bar. Now we have modulus of z1, modulus of the product z1 z2 is equal to modulus of z1 multiplied by modulus of z2. Use that one. This will be equal to mod of minus I into mod of z bar. Mod of minus I is 1. Mod of z bar is same as mod z. But now mod z square will be same as mod z square, that is equal to mod z. So mod z square minus mod z is equal to 0. So mod z multiplied by mod z minus 1 is equal to 0. This implies mod z minus 1 is equal to 0, because mod z not equal to 0. That will give you mod z is equal to 1. So what is that we want? We want mod of z square. Now mod of z square is same as mod z square, and mod z is equal to 1. 1 square is 1. So let's look at our options. Our answer 1 appears against option 4. The answer to this question is option 4. That is the detailed discussion of the solution of the problem, and it is a very simple and straightforward problem. I am sure that you have understood the solution of this question. Let's now move to the next question, question number 9, and this question has appeared in the JEE Main exam held on 30th January 2024 in the second shift. If z is a complex number, then the number of common roots of the equations, two equations are given. The first one is z to the power of 1985 plus z to the power of 100 plus 1 is equal to 0. The second equation is z cube plus 2z square plus 2z plus 1 is equal to 0 is equal to. So we have to find the number of common roots of these two equations. Let's now discuss the solution of the problem in detail. We have two equations. The first equation is z to the power of 1985 plus z to the power of 100 plus 1 is equal to 0. Let's call this as the equation 1. The second is a cubic equation given by z cube plus 2z square plus 2z plus 1 is equal to 0. Call this as the equation 2. Now it is easier, the degree of the first equation is a very big degree, 1985, and the degree of the second equation is 3. So the easiest will be to talk about the second equation because its degree is the lowest. Agreed. Let's take that required to find the number of common roots of the equation 1 and 2. So first we take the first equation. Z cube plus 2z square plus 2z plus 1 is equal to 0. So we combine z cube and 1. Z cube plus 1 is z cube plus 1 cube. So a cube plus b cube formula you use. So it will be z plus 1 into z square, z plus 1 into z square minus z plus 1. And 2z square plus 2z, take 2z common, 2z into z plus 1. So we got this one. And now we find z plus 1 is a common factor. We take out z plus 1 and that is equal to z square minus z plus 1 plus 2z. And that is z plus 1 into z square plus z plus 1 is equal to 0. Z is equal to minus 1. The second one is z square plus z plus 1 is a very familiar equation and whose solutions are the complex cube roots of unity, omega and omega square. So z is equal to minus 1, omega and omega square are the roots of the second equation. So common roots means you have to find out whether minus 1 is a root of the first, omega is a root of the first, omega square is a root of the first. These three cases you have to consider. Agreed. Let's get into the first equation. This is the first equation. So now if you substitute z is equal to minus 1. Minus 1 to the power of 1985 is minus 1. Plus minus 1 to the power of 100 is 100 being a even number, it is plus 1 plus 1. So minus 1 plus 1 plus 1 is not 0. Therefore z is equal to minus 1 does not satisfy the equation 1. Therefore z is equal to minus 1 is not a common root. So what about z is equal to omega? Now you have to remember the properties of the complex cube roots of unity. One property is omega cube is equal to 1. Right. So you take z is equal to omega, substitute in this. So omega to the power of 1985 plus omega to the power of 100 plus 1, is it 0? That's the question. So omega cube is 1. Therefore, this you can split as a 1983, which is a multiple of 3. And the z to the power of 1983, which is a multiple of 3. Therefore, that will give you 1. So, omega to the power of 1985 is same as omega square. Omega to the power of 100. Omega to the power of 100. Omega to the power of 99 is 1. Right? Because omega cube is 1. So this will give you omega plus 1. So if you have this equation, the first one will give you omega square plus omega plus 1. And the properties of the cube roots of unity are 1 plus omega square is equal to 0. So this will give you z is equal to omega is a common root of 1 and 2. So you again take z is equal to omega square in this. So this will be omega to the power of 3970 plus omega square wholes to the power of 100, omega to the power of 200 plus 1 is equal to omega to the power of 3970 is omega. Omega to the power of 200 is omega square plus 1, that is equal to 0. So omega cube is equal to 1, that is what you have to use in all these things, and 1 plus omega square is equal to 0. So that will give you z is equal to omega square is a common root of 1 and 2. So that's we have found two common roots. They are omega and omega square. So therefore, the number of common roots of those two equations are 2. There are 2 common roots. So let's look at our options. Our answer 2 appears against option 2. Therefore, the answer to this question is option 2. That is the detailed discussion of the solution of this problem. And it is also a simple question, but it may take little bit of time, right? So I am sure that you have understood the solution of this problem. We move to the next question. That is the last question for this video. And the question has appeared in the JEE Main exam held on 31st January 2024 in the first shift. If alpha denotes the number of solutions of this equation, mod of 1 minus I to the power of x is equal to 2 power x, and beta is equal to mod z by argument of z, where z is equal to pi by 4 multiplied by 1 plus I to the power of 4 multiplied by 1 minus root pi I by root pi plus I plus root pi minus I by 1 plus root pi I, right, where I is the imaginary unit. Then the distance between the distance of the point alpha comma beta from the line 4x minus 3y is equal to 7 is. So alpha denotes the number of solutions of this equation, and beta is the mod z by argument of z, where z is given by this one. Then you will get alpha and beta. Thus you get a point alpha comma beta, and required to find the distance of this point from this line. Let's now discuss the solution of the problem in detail. Right. Given alpha denotes the number of solutions of this equation, mod of 1 minus I to the power of x is equal to 2 power x. Modulus of 1 minus I is under the square root of 1 square plus 1 square, that is square root of 2. So this will be square root of 2 to the power of x is equal to 2 power x. So square root of 2 to the power of x means 2 to the power of x by 2 is equal to 2 to the power of x. The bases are same, therefore the powers must be equal. X by 2 is equal to x will give you x is equal to 0. So that is the only solution. Therefore the equation has only one solution, namely x is equal to 0. So alpha denotes the number of the solutions, therefore alpha is equal to 1. Agreed. Now, to talk about beta, we take the z. Here z is given by pi by 4 into 1 plus I to the power of 4 into 1 minus root pi I by root pi plus I plus root pi minus I by 1 plus root pi I. Now what I will do is 1 plus I whole to the power of 4, I will write it as first 1 plus I whole square and then square. And 1 plus I whole square is 2I. That way 1 plus I whole to the power of 4, we will write it as 2I square. Pi by 4 into 2I square. Now get into inside the bracket, and the first one we take and rationalize the denominator. To rationalize the denominator, multiply and divide by root pi minus I. The second one, rationalize the denominator, multiply and divide by the rationalizing factor 1 minus root pi I. So this will be equal to pi by 4 into 2I square into rationalization is taking place here. And if you see the denominators, it will be root pi plus I into root pi minus I is pi plus 1. And this is also 1 plus pi. 1 plus pi. Now what you see is pi plus 1 here, 1 plus pi, the same denominator is there, and you find the numerators are same, so it will be 2 times of this 1 by pi plus 1, pi plus 1. And here 2i square, we write it as 4i square. 4i square is minus 4. So this will be equal to pi by 4 into minus 4 into 2 times of 1 minus root pi I multiplied by root pi minus I by pi plus 1. Now multiply, just multiply. So 1 into root pi minus, so this will be pi by 4, 4 cancels, and it is minus 2 pi into multiplication. Root pi into 1, root pi, minus root pi into root pi I is pi I, minus I, plus minus into minus, plus, of course, but I into I square. That is why there is a minus coming in. So root pi. So root pi cancels, and you take a minus I common here. Minus I into pi plus 1 by pi plus 1. So minus 2 pi, minus I into pi plus 1 by pi plus 1, pi plus 1 cancels, and it will be 2 pi I. Agreed. Take this, get into beta now. Beta is equal to mod z by argument of z. That is equal to mod of z is mod 2 pi I by argument of z is 2 pi I, argument of z. So mod of 2 pi I is 2 pi, mod I is 1. So argument of 2 pi I is a complex number. So argument is tan inverse of y by x, tan inverse imaginary part by the real part. The imaginary part is 2 pi, the real part is 0. So it is tan inverse infinity, that is pi by 2. So 2 pi by 2 is equal to pi cancels, is equal to 4. Thus we got alpha is 1, beta is equal to 4. Thus we got alpha comma beta, the point 1 comma 4. And we want the distance of the point 1 comma 4 from the line 4x minus 3y minus 7 is equal to 0. So use the perpendicular distance formula. That will be modulus of 4 into 1 in the place of x, alpha, right, minus 3 into beta, the 4, minus 7 by under the square root of 4 square plus 3 square. And that is equal to modulus of simplification minus 15 by 5, that is minus 3. Modulus of minus 3 is 3. So the distance is, the answer to this question is 3. It's a numeric value question, therefore the answer is 3. That is the detailed discussion of the solution of 5 questions what we have discussed in this video. I am sure that you have understood all these 5 questions, and I wish you all the best. Thank you.